Hi guys, this is Aditya and we are going to solve problem of the day on GFG. So let's see the problem. Find the closest number. Okay, the question is given a sorted array of a positive integer. The task is to find the closest value in array to the given number k. The array may contain duplicates value. If the difference with k is the same for two value in the array, return the greater value. Okay, so uh, this problem is very easy. Uh, you can see here that the number is already in sorted. That means the array is already in sorted way. So one thing you can assure here that you can apply here binary search because the array is sorted. Okay, that's cool. And so see how can we solve this problem. The expected time complexity is long n. Okay, so let's take analyze this test case. So we get that point here. K is equal to yeah, K is equal to here K is equal to here 4. Okay, K is equal to here 4. Okay, and the number is 1 2 3 5 6 8 9. 1 2 5 6 8 9. 1 2 3 5 6 8 9. 1 2 3 3 is here. Okay, so the we have to find the closest value. So which one is the closest to 4? That 3 or 5. So both we can say 3 and 5 is closest, but we have to if the closest is same, that is closest absolute difference, like 4 minus 3 is 1. Okay, and 4 minus 5 we are taking here mod value. Okay, so that is 1. Okay, so this distance 4 minus 3 and 4 minus 5 is same. So in that case you have to return the maximum number. That means 5 is the maximum from 3, so 5 is my answer. Okay, 5 is my answer. Okay, that's cool. So in that particular case, so we can apply here binary search. How can we? So one thing we know that it is already in sorted way. So if we will find if we will find that number which is uh, that number, like 4 is my number, the greater number, either we will find the greater number the 4 or lesser number of the 4. That either if I will find the 3 or if we will find the uh, 5, then we can find easily. Okay, so those guy who solve in C++ who know about the lower bound, lower bound. Okay, so lower bound is uh, actually it is doing like that. It finds the uh, lowest number. It's find if the element is present, then it finds the. Okay, let me show a sample, then you can understand easily how the lower bound actually work. So if my number like in this way 1 2 3 3 3 4 let's say is called 6, okay, 7, okay. If I want to find the 3 in the given array, and array should be sorted, then we can apply this. So my lower bound tells the position at this point, because this is the first element, that it should be the greater than 3, but the first element which encountered, that element is the lower bound of the 3, okay. So my lower bonds gives me the position of 3 in the array, the first element of the 3. Let's see, if I will find the 4, if I want to find the 4, so you can see here there is a no 4, so which position uh, give me, so this will give a 6, this number, 6 number, okay, this position, it cannot give this position, okay, because it's always find the equal to or greater than the lowest, greater than the smallest, greater than the 3, okay. So 6 is the smallest greater than 3. It cannot send 4, it's 7, it always send 6, because sorry, we are finding 4, so the smallest greater than 4 is 6, so 6 is my position the lower bound gives me, okay. So similarly, for the question is that we have to tell the closest value of the given number, okay. So here we are finding 4, okay. So if we will find the, if we will find the lower bound of 4, so which position is lower bound of 4, so which position should be the answer, which position gives me at 5, this position, okay, this position lower bound tells me, so I will pick this position, okay, and subtract from k, 5 minus k, so it's give me 1, okay, we are taking here absolute, okay, and this position can be possible, it may be the lowest value, because one thing we know that the if this is my k, so closest can be here or can be here, can be in this side or can be in this side, okay. So we have to consider both sides, so we have to consider in this side and in this side, because 4 lies here, okay. So we got 5, so we need to check 5 minus sorry 3 minus k, so both are 1, so we need to send 5 because 5 is my greater element, okay. This is the case, okay. So okay, let's go to the code section. So this is the code. Here I am finding the lower bound of the k, that means if 1 2 3 5 6 8 9, if I finding the lower bound of 4, it will give me the position, this one at 5, okay. So this one, this index is my position, so I will find its position it minus array, so it will give me index 0 1 2 3, 3 is my position, okay. So one thing here is edge case, I will tell you later, and then I am taking here answer for num1 which is int max, num2 which is int max, okay, because I need a smallest number, okay. Here I am apply, maybe the element is not present, like maybe I want to find here 12, okay. So 12 will be lie after this 9, after this, okay. after 9, 9, 12. So I don't have 9 because the lower bound always gives the higher value. If 12 is not present in this array, then it will send the length of the array. Okay, so it will send the length of the array. That means it is out of bound. Okay, this is the first case. Then if it is present, then I will take the distance between this. And one thing, if like this is the case equal to 4, so we will give 5. So I will int minus 1 and minus k, that means 3 minus 4, that will give me 1. And one thing is, we must assure that the int should not equal to 0. Maybe the element, maybe the position, the lower bound gives me the 0th positions, so we cannot go the negative index, it's out of bound. So that thing we should care about it. Okay, so we got two distance, num1 num2, that is either left or either right. Okay, so if num1 is greater than num2, so I will send left. If num2 is greater than num1, so num1 is the smallest, so definitely array int is my answer, that is left. If it is not getting the num1, that it should be the int max, so int max is definitely the higher value. If it is both are equal, and that case those have maximum, I will assign into the answer. Okay, that is the case. One thing is that if the array int, like if my k is equal to 5, so which is the closest element? 5 is all, because 5 is present in this section, so definitely my lower bound gives me this position, so definitely it will be 0. So this is my answer. Okay, so this is the edge case. So it always gives a 0, so it will return k. Okay, so what is the time complexity? The time complexity should be log n, because this will take log n for finding, because it's already sorted order. And this will take of one time complexity, and about a space we are using as constant space. Okay, thank you.